Hello everyone. Hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT/IC department. Welcome to the video tutorial series of the data communication and the computer networks. Today we will discuss the transmission media by which we are sending the data from sender to receiver, right? So let's see what we are going to cover in this today's session. Before that, let's have a quick recap about our previous session, right? So for that quick recap about that previous session is what we have learned in our previous session. So we have seen that the introduction about the data communication, we have seen the data communication model. After that we have seen the functional characteristics about the data communication, the components which are used for the data communication, and the data flow, how the data is flowing in the data communication. We have seen the networks in brief, the network criteria, why the networks are used, and the attributes about the networks. And then we have seen the topologies, right? The physical structure of the network is we have seen, right? So let's move forward about today's session. So outline of the today's session is, first of all we have seen that the transmission media, right? So why the transmission media are used, the purpose of the transmission media we will cover first. After that we will see it's one type, guided media, which have the three subtypes: twisted pair cable, coaxial cable, fiber optics cable, right? And then we will see the propagation mode and transmission impairment, right? So let's start with the transmission media. So what is its purpose? The purpose of the transmission media is it transmits the raw bit of the one machine to the another machine, right? So with the help of the transmission media, you are able to transmit a raw bit from sender to receiver, or you can say that from the one machine to another machine, you are sending the raw bit with the help of the transmission media, right? So this is the major purpose of the transmission media. The various physical media can be used for the actual transmission. The various physical media can be used for the actual transmission, right? So it can be the guided or unguided, right? Or for an example, for the guided media we are using the wire technology, and for the wireless communication we are using the sum of the wavelength for the transmission, right? So there are the various physical media that can be used for the actual transmission, that each transmission has each of its own in terms of condition, right? So bandwidth, delay, cost, as of the installation and the maintenance are the major terms and condition for that transmission media. We use different types of cable or waves for the transmission media, as we have seen that the various kind of physical media are used, right? So for that the cables and the waveforms are we are using to transmit data from sender to receiver, right? So this is the purpose of the transmission media. After that, so what is the transmission media according to you? Have you heard transmission media term before? The transmission media is a pathway that carries the information from sender to receiver, right? So data is transmitted normally through the electrical or electromagnetic signal, right? So have you one question arrives there? How the data is transferred from one sender to a receiver? So the data are transmitted normally through the electrical or the electromagnetic signals, right, with the help of transmission media. So where does the transmitted media located? The transmitted media are located below the physical layer. Computer use the signals to represent the data, and that signals are transmitted in the form of electromagnetic energy, right? So you can observe that the transmission media is below the physical layer. The data is come from the physical layer, is transferred to the transmission media, and the transmission media is transferring the data from the one sender to the another receiver, right? So the transmission media will transfer the data from the physical data of the senders to the physical layer of the receiver end, right? So in the middle the transmission media is there, right? So this is about the transmission media. The classification about the transmission media, which are the major its type, right? So basically the transmission media has mainly two types: guided media and the unguided media. In the guided media they are use of wiring technology, There are the several kind of wires which we are using for the transmission, right? The actual transmission. We are using the actual wiring for the transmission. There are so many types: twisted pair cable, coaxial cable, and the fiber optics are the majorly used cabling system in the data communication, right? So in the guided media, the twisted pair, coaxial, and the fiber optics are there. And in the unguided media, it is wireless, right? So for that we are using some kind of wavelength, radio wave, microwave, and the infrared wave signals are we are using for our transmission to our send the data from sender to receiver, right? So there are three types: radio wave, microwave, and infrared. So there are its two types: guided media and unguided media. In that, twisted pair cable, coaxial cable, and fiber optics we will see in brief, right? So let's start with the guided media. What do you mean by the guided media? As we have seen that it has mainly three types, right? Guided media is a wiring technology where we are using the three kind of wire: twisted pair, coaxial cable, and the fiber optics, right? So there are the majorly three types of the guided media. After that, let's begin with the twisted pair cable. What do you mean by the twisted pair cable and where it is used? The twisted pair cables are one of the oldest and still used in the cabling system. The twisted pair consists of the two conductor, right? So basically insulated copper based in the helical form, just like an DCN, right? So in the twisted pair cable, there are the basically two conductors which are used to conduct your data. That conductors are insulated with the copper base, right? And they are wrapped around with its own plastic insulation. The twisted are together, right? So you can observe that this is the insulator, and in that insulator there are the main conductor there, which is mainly based on the copper, right? So this is the formation of the twisted pair cable. What does it provide? Why does this twisted pair cable are used? It provides the protection against the crosstalk or the interface, right? So the insulation are used for providing the protection against the crosstalk or the interface, or we can say that noise. One wire here in the twisted pair cable, two conductors are there, right? So what are its functionality? In that, the one wire is used to carry the signal to the receiver, where the second conductor, the second wire is used as a ground interface, right? For the twisting after receiving the signal, it remains the same, right? So why we are twist the cable? We are twisting the cable for receiving the signal that remains the same. Therefore, the quality of the twisted pair cable is assigned by the number of the twist per unit length that determines the quality of that cable, right? So for an example, you get the n number of twist per foot or n number of twist per meter. They decide its quality of that twisted pair cable, right? So this is about the twisted pair cable, and let's see its two subtype, right? So twisting is done cause two parallel wire are constitute the fine antenna. So when the wires are twisted, the waves from the different twist cancel out, so wire radiates the less efficiently, right? So that's why we are twisting the cable in the twisted pair cable, right? So advantages, the main advantages of the twisted pair cable is really cheaper compared to other cabling technology and easy to work with, right? So this is the major advantages about the twisted pair cable is it's cheaper and easy to work with. The major disadvantages about the twisted pair cable is the low data rate and the short range communication. With the help of the twisted pair cable, you can only transmit the data in the short range, right? So this is the major disadvantage about the twisted pair cable. There are some of the application about the twisted pair cable. It is very common medium, right? It can be used in the telephone network, the connection within the building. We are using the twisted pair cabling. For the local area network LAN, we are widely use the twisted pair cable for the cabling system. You might have the internet connection at your home, so they are using this kind of wires, right? They are using the twisted pair cable for your LAN connection, right? Or your internet connection, right? So this is the basic application about the twisted pair cable. It has a mainly two types. Unshielded twisted pair cable, we are saying that the UTP, and the shielded twisted pair cable or STP, right? So let's begin with the unshielded twisted pair cable. So what is the difference between the unshielded and shielded? A pair of the unshielded wires are wound around each other in the UTP. In the unshielded twisted pair cable, it is really easier to install, as you can observe in the figure that the two pair of the unshielded wires are wound around each other, right? They are twisted with each other. On that, they are the plastic insulator, or you can say the plastic cover there. The basic application about the UTP is the telephone subscriber connect to the central telephone offices, right? So this is the basic application about the UTP. It offers the LAN connectivity of the 10 Mbps to the 100 Mbps, right? So this is the application about the UTP. The unshielded twisted pair cable and its connector are, you can see there. So this is the RJ45 cabling which are used with the twisted pair cable, the UTP, right? So for the work with that UTP and RJ45, we use the crimping tool for this kind of connection, right? So this is the connectors and tools used with the unshielded twisted pair cable. The advantages of the UTP, it is really affordable, right? The most compatible cabling system nowadays is the UTP. It is used in the major networking system, as we have discussed that whenever you are having an internet connection in the short distance, right, from the local internet provider, your ISP, you are having the internet connection, right? So from that location to your home, they are using the twisted pair cable, and in that they are using the UTP mainly. The disadvantage of the UTP, it suffers from the external electromagnetic interface. This is the major disadvantage about the UTP, right? After that, let's see another type of the twisted pair cable, which is shielded twisted pair cable, right? So pair of the wires are wound around each other and other are placed inside the protective foil wrap. As you can see that in the figure, that the wires are rounded around each other and they are placed in the protective foil wrap, right? So metal braid or the sleeve of the foil that reduce the interface. That's why we are using the shielding, right? It is handled to, why it is difficult to work with the STP, it is harder to handle because the wire is really thick compared to UTP and it is heavy also, right? You can observe the real life photograph of the STP is, you can observe that, right? So where their wires are wrapped around the protective shield, right? So this is that's how the STP is built. Let's see some of the application of the STP. The STP is used in the IBM token ring networks, right? Where the higher transmission rates over the long distance is required, they are usually the STP is used there, right? So this is the major application about the STP. The advantages and the disadvantages about the STP. The STP is shielded, right? So this is the major advantages about that. It is faster compared to the UTP, right? We can see that where the higher rate of transmission media is there, so we are using the STP compared to the UTP. The disadvantage of the STP is it's little more expensive than the UTP because it's having the protective foil wrap around that cable, right? The high attenuation rate is present in the STP, right? So this is the major advantages and the disadvantages of the STP, right? So after that, let's move forward about the another cabling type, right? That's all about the STP and twisted pair cabling. After that, the major cabling system is work with the coaxial cable. So coaxial cable carries the signal of high frequency range than the twisted pair cable, right? So coaxial cable. So this is the basic structure about the coaxial cable, right? So the inner is the conductor, is the solid wire. As you can observe in the figure that the core is a solid wire by which you are transferring your data. The outer conductor is served as a shield against the noise and the second conductor, and in that they are insulator are used. right? You can observe that in this figure that this is the main inner conductor, that is the solid wire, and after that there are the outer conductor also there, right? This is used for the shield against the noise, and the second conductor, right? So this is the structure of the coaxial cable, right? After that, the categories of the coaxial cable, there are the mainly three category of the coaxial cable. You can observe that RJ59, RJ58 and RJ11, right? They proposed and different kind of impedance, and the use of that cables are different, right? So RJ59 is impedance the 75 ohm, and which are used for the cable TV and the analog transmission, where the RJ58 is used for the thin Ethernet and RJ11 are used for the thick internet, right? So coaxial cable are categorized by the radio government, the RG rating, and RG is the de jure standards, right? So this RG stand for the radio government, right? So this is the basic category of the coaxial cable, right? So for to work with the coaxial cable, there are the different kind of connection available. BNC connector, Bionz-Neal-Colsman, right? To connect the coaxial cable to the device, we need a coaxial connectors, right? So BNC connector is used at the end of the cable to the device. For an example of the TV set connection, right? BNC T connector is used to the Ethernet network to branch out the connection to the computer or other devices, right? This is the BNC T connector. The BNC terminator is used at the end of the cable to prevent the reflection of the signal, right? So there are the basic connectors which are work with the coaxial cable. The major application about the coaxial cable, it is the most versatile medium, right? The television distributors are widely use the coaxial cabling, right? You have observed that in their past history they are used the coaxial cable for giving us the table KV connection. The long distance telephone transmission are used the coaxial cabling, right? It can carry and 10,000 voice calls simultaneously on the single line. The short distance computer systems linking uses the coaxial cabling, and coaxial cable are also used in the local area networks, right? This is the application about the coaxial cabling. After that, let's see the advantages and the disadvantages about the coaxial cabling. So in the advantages, it is easy to wire and easy to expand the network, right? The moderate level of the electromagnetic interface is provided by the coaxial cable, so people are attracted towards the coaxial cable. The high bandwidth and the excellent noise immunity is another advantages of the coaxial cable. After that, let's see the disadvantages of the coaxial cable. If the single cable failures can take down the entire network, right? The cost of the installation of the coaxial cable is high due to its thickness and stiffness. The cost of the maintenance is also high where you are working with the coaxial cable, right? So let's move forward about this another type of the cabling, the fiber optics. You can say that the new era of the data communication, the fiber optics offer that the 50,000 Gbps, right? So with the help of the fiber optics, we can achieve the 50,000 Gbps speed. It can be achieved in the laboratory. We are able to gain and achieve 100 Gbps, and currently practicing the signaling at the 10 Gbps, and currently we are using the 10 Gbps line with the help of the fiber optics in our day-to-day life, right? Our inability to convert between the electrical and the optical signal faster, that's why we cannot achieve the peak, or we cannot achieve the threshold of the fiber optics cabling, right? Scientists are looking very hard for the better technology and the material which can convert the electrical and the optical signal faster, right? So if we are able to convert the electrical and the optical signal faster, we can get an higher speed with the help of the fiber optic cabling, right? So let's see how it's working. The fiber optics cable is made of a glass or a plastic. and transmit the signal in the form of light, right? So let's see the nature of the light. The light travels in the straight line. If light goes from the one substance to the another, then the ray of the line changes its direction, right? So if you are transferring the light from one substance to the another, then the ray of the light changes its direction. The ray of the light changes the direction when it goes from more dense to the less dense substance, right? So this is the nature of the light. After that, let's see the bending of the light ray, the angle of the incidence, right? The angle of the ray that makes with the line perpendicular to the interface between the two substance is called the angle of incidence, right? As you can observe that this is the angle of the incidence we are measuring from, the angle which is made from this light ray with that perpendicular of that interface of the two substances, right? So this angle is called the angle of incidence, I. After see, we have seen that if the light is traveling from the more dense to the less dense substance, it changes its direction, right? So you can observe that it is changing its direction from straight to the slightly bending, right? So likewise, if we are changing the angle of incidence, somehow we are able to reflect the light in that particular angle, that it will be reflected at the 90 degree with the surfaces, right? So for that, let's see the critical angle. At the angle of the incidence which provides the angle of the reflection of the 90 degree is called the critical angle. In the second figure, you can see that what is the critical angle. The line is at the angle on that, the angle of the incidence on that, the line is reflecting toward the 90 degree, it is called the critical angle, right? So that's how, if we are increasing the angle, then the light reflection is changing. So if we are reflecting the light greater than the critical angle, then that light will be reflected back into that particular substance only, right? So by this property, we are transferring the data in the optical manner in the optical fiber cable, right? So that's about the how the light is bending. The three key components are there: the light source, transmission media, and the detector. Uses the reflection to guide the light through the channel, right? Core is of the glass or the plastic surrounded by the cladding. In the fiber optics cable, the base is made from the glass or the plastic, which is surrounded by the cladding. The cladding is of less dense glass or plastic material, right? So you can observe the construction or structure of the fiber optics cable. There you can observe that the inner core is made from the glass and outer core is made of the plastic, right? After that, there are the steel wire there to protect that wires from the breakdown and the failure, right? The high density polyethylene polymer is there, right? So this is the structure, the construction about the fiber optics cable, right? This is the connector which are used to work with the fiber optics. Let's see the application about the fiber optics. This is the new era of the data communication, right? So it has the wide range of the application. The telecommunication uses the fiber optics cabling. After that, the fiber optics nowadays are used in the local area network also, right? For the higher speed transmission, high speed transmission, the cable TV, CCTV camera, and the medical education uses the fiber optic cables, right? This is a major application about the fiber optics cable. Let's see the advantages and the disadvantages first. So let's move the forward about the advantages. The advantages of the fiber optics cable is the greater capacity. For an example, data rates at the 100 Gbps, right? So it is really unbelievable. The smaller size and the lighter weight. The cables are small in the size and lighter in the weight. That's why you can attract towards the fiber optics cable. Its offer and low attenuation. The electromagnetic isolation is there, right? So fiber optics is already working with the optical rays only. It is working with the light ray only, right? So it is isolated from the electromagnetic form. the more resistance to corrosive material, right? The greater repeater spacing facility, right? So it offers the greater repeater spacing facility. For an example, with the use of the fiber optic cable, you can transmit the data towards a few kilometers, right? After every tenth of the kilometer at least, you can transmit the data, right? The repeaters are lesser required for the work with the fiber optic cables, right? So this is the advantages about the fiber optics. Let's see the disadvantages about the fiber optics cable. The installation and the maintenance need an expertise, right? To work with the fiber optic cable, we need an expertise people to installation that cable, and to maintain that we need an expert there. Only fiber optics cable gives an only unidirectional light propagation, right? We cannot have a two-way propagation in that fiber optics. It is much more expensive than the other cabling technology. That's why the fiber optics cable are laser use, right? In the laser use. So that's about an fiber optics cable. Let's see the some transmission impairment. So attenuation means the loss of the energy. Right after that, the distortion. The distortion means that the signal changes its form or shape. Whenever you are transmitting the data with the transmission media, if our signal is losing its energy, it is called the attenuation. If it is changing its shape, then it is called the distortion. And if another waves are product them, the noise is then another cause of the impairment, right? So this is the major cause of the impairment. There are the several type of the noises. For an example, thermal noise, induced noise, crosstalks are the basic example of the noises, right? So in this session, we have seen the transmission media in brief, and we have discussed about its one type, the guided media, where the cabling technology is used. There are the three major kind of cabling technologies: twisted pair cable, coaxial cable, and the latest one, the fiber optics cabling. We have seen its used, application, advantages, disadvantages, and its structure, how they are constructed, right? So this is all about today's session. Thank you for the watching.